Hello everyone, welcome to the course Digital Image Processing. I am Dr. Ujjal Vishwas, Assistant Professor, Department of Computer Science and Engineering, NIT Manipur. We are discussing the topic on compression for digital image processing. Now today we are concentrating on the topic which is morphological image processing. This morphological image processing, why it is required, and what are the techniques or what are the methods used to process this morphological image processing, we are going to discuss. Now, morphological image processing is a technique for structuring and processing the structural features in images, particularly useful for binary image. So, for a binary image, how these structural features helps in morphological processing. Now, it also involves structuring the elements to provide the image and modify its shape based on the interaction between the structuring elements and the image components. Now, if we think about the morphological image processing technique, these morphological image processing techniques includes four key steps. This starts from the preliminaries. It based on a set theory and structuring the elements. Mostly, this basic operation includes this dilation, erosion, opening, and closing technique for basic operation on set and structuring elements. And then also this advanced transformation of this morphological image processing transforms into this hit or misses transformation. And in the next, it includes some basic algorithms with the boundary instructions for identifying the boundary of the image, and also region filling. That means it progressively region filling helps to generate the region, and skeletonization and thickening the image. So based on these, the details are as follows. These preliminaries are required for morphological operations. I have already discussed in the previous figure, that these morphological operations are based on a set theory and involve defining the sets and operation for image regions. And it also depends on the structuring the elements, that is nothing but the image elements here is a small shape or pattern used to provide the image for generating a particular shape or image. Now this next one is the dilations. This dilation actually helps to enlarges the object in an image by adding a pixel to the boundaries, and it is performed by sliding the structuring elements over the image, and for each position setting the output pixels to 1 if at least one pixel in the structuring element overlaps with the pixel in the image. This is the technique for a dilation on a image pixel informations. Now, the second one is the erosion. This erosion shrinks the object in a image by removing boundary pixels. So, shrinks the object shrinking is another importance of this morphological image compression technique. It is performed by sliding the structure element over the image. and also it concentrate on each position of the pixels, and the setting the output pixel to 1 only if all pixels in the structuring element overlap with pixels in the image. So when it overlaps the pixels in the in the image, then that pixels we make as a 1. Now this opening this opening is an operation that consists of erosion followed by dilation using the same structuring element. So opening is nothing but the combination of both erosion and followed by dilation using the same structuring elements. Now it removes the small object and smooths the continuous of larger objects. Now the next one is the closing. This closing is an operation that consists of dilation followed by erosion. This is also the combination of both two, this erosion technique and dilation technique, that same structuring, and it operates on the same structure elements. It also fills small holes or smooths the contours of objects. So contours of object is smoothing the image, helps to smoothing the image after this morphological processing. Now next is heat or this mist transformation. Now what is this heat or mist transformation is used? Why it is used for it is helping or detecting the specific shape or pattern in a binary image. It helps actually identifying the pattern into a binary image. It involves two structuring elements, one for the foreground and one for the background. So if sometimes it is also required to differentiate between the foreground and the background of the images, and for a digital image processing, this foreground and the background image pixel values are very important. So for it involves using two structuring elements. So for these two structuring elements, it operates on these two components only. This transformation detects the location where the foreground structuring element matches the foreground pixels and the background structuring element matches the background pixels. So sometimes it helps to differentiate between this foreground and background, removing the backgrounds on the image. So that are the major objective of these heat or mist transformations. Now these basic morphological algorithms, there are many important components for these morphological algorithms. So the key points of these boundary extractions, the most important component is the boundary extraction. For any image, boundary identification is a very important part of digital image processing, and these algorithm extracts the boundary of an object by subtracting the eroded image from the original image. So next one is the region filling. So region filling, iterative process, and region filling is the next algorithm. This algorithm fills the holes or is smoothing the image in an object by iteratively dilating the object and intersecting it with the complement of the original image. So this one another popular techniques, which is this skeletonization. These algorithms reduces an object to its skeleton, which is a thin representation of the object shape, and this thin representation of an object is known as this skeletonization. And now thickening the image. These thickening algorithms helps to thicken an object by adding the pixel to its boundary. So, so these are the major technique in morphological algorithm representations. So thank you.